Thank you very much. It is a great pleasure and truly an honor to be part of the David Keeling Memorial Lectures and to be talking on our common climate. Climate doesn't stop at the border, and ecosystems and biodiversity do not respond to artificial boundaries. That's why it's very important to work together in all these issues that we share and have in common. In my talk, I will highlight some of the climate drivers and some impacts that we have seen on both sides of the border. Some of the impacts sometimes are stronger on the Mexican side because that depends very much on structural adaptation. Urban development, and we see very strong differences, especially between San Diego and Tijuana. So what do we share? We shared a semi-arid climate, water, and from Ensenada, which is like 100 kilometers south of the border to the north, we share this beautiful Mediterranean climate. This climate is basically due to a high pressure cell that sits here most of the year. It's like a barrier in the ocean that doesn't allow the entrance of moisture to the continent, but during the winter, the high pressure weakens and allows the entrance of channels of winds that move up in the atmosphere. We see atmospheric rivers coming in, cold fronts coming in from the north, and those the interaction of those different events produce rainfall, snowfall in the mountains, and depending on these winds that we have here, depending on the position, that will be the impact or the entrance of moisture and the influence that we will have at local scale. So we also share in this region the waters of the Colorado River. Baja California depends, especially the border area, depends very much on the water of the Colorado River. We also have a California current here in the ocean, and we have impacts of different events that are far away from us but have an influence locally, and I will talk about later. And of course, from time to time, like last year, we have the entrance of some tropical cyclones, depending on the conditions of the ocean. The sources of water for the Pacific states are basically related to winter storms. And these winter storms are related to these winds that move up in the atmosphere that we call jet streams. We have a jet stream that sometimes moves close to the border, and the other one that moves around the Arctic. And depending on the intensity of those winds, the intensity and also the position of these winds, we will have possibly the entrance of moisture, or like in this event, like La Niña event, we have influence from far away, from the equator, for example. When it is cold, we have an event that is called La Niña. Possibly you have heard in the news about El Niño and La Niña events. La Niña events is when the ocean here in the equator is cold, and that pushes away these currents that we have here, and therefore they are far away from the border, and the cool and wet regions will be farther north, and here it will be dry. The opposite situation occurs when we have an El Niño event. The ocean here is pretty warm, warmer than usual, and therefore will create teleconnections or connections to this area. It will move down the jet stream, these winds that move up in the atmosphere but interact very much with the cold fronts and with the atmospheric rivers in this region. I don't know if you have heard in the news, especially during the winter season, about the polar vortex. The polar vortex is when the jet stream, these winds up here around the pole, when the winds are very strong and in this direction, the cold stays in the Arctic. But when these winds are weaker than normal, then the jet stream, or the polar jet that we call it, start to meander. And when it meanders, then it can interact with this one, and therefore we will have cold air coming down, and the warm air from here will go up. And that creates extreme events that are not common, for example, in Canada, or here we have very cold air going down to the tropics, and that changes and produces extreme events and sometimes hydroclimatic situations. This past winter, we had an El Niño event, sort of like this current of winds in the upper atmosphere were in this direction. We had a number of atmospheric rivers, this moisture that comes from the Pacific and produce a wet winter in this area. So the jet streams, this is the one that we have close to our region. When it is strong, both in the Pacific and in the Atlantic side, we say that we have an extended jet stream, and that produces wet conditions in these regions. And when this is the case when the polar jet, it is weaker, and therefore it starts to meander all over the globe and brings cold air to the south, warm air to the north. And that's why sometimes in winter, in some regions up in the north, in the mid-latitudes, they have heat waves because the warm air goes up to the north warmer than they used to have it at those latitudes. So the interaction between this polar jet and the jet here in our region that we call a subtropical jet is very important to create all these different extreme events that we have here. Sometimes during the opposite situation, this is a kind of a Niño type situation, but when we have La Niña, that the jet stream goes up to the north, sometimes this side of the jet, that we call it the Atlantic side, is inclined with this slope and allows the entrance of moisture toward the central United States and to this part of the western border region in Mexico, and sometimes also in Arizona and New Mexico we have entrance of moisture and atmospheric rivers. So not only during El Niño events, but in different in other situations, we can have atmospheric rivers or moisture arriving to the continent. Our region that has this semi-arid climate, it used to be, it is used to climatic surprises because we have a lot of variability. This means that one year we may have a very wet year, and then 2-3 years we may have dry years. So it is common in our region. We're used to that. However, in the last decade, we have seen several hydroclimatic surprises, more different or more extreme than we are used to. And this, when these changes in the circulation happen, then that affects a lot of decisions and activities, because seasonal economic activity depends sometimes on knowing that this year will be wet. But if that doesn't happen, that creates some problems. And year 2004-2015, we had one of those extreme events that we call it El Niño Godzilla, because it was supposed to be super, super warm here in the Pacific Ocean, and we were expecting a very wet winter because El Niño years, as I mentioned before, the jet stream used to normally is over here, and therefore brings moisture toward the border region. That was what we expected, but that didn't happen. What happened is that there was a warm area here. We see it in this area. And that created division in the jet. One of the jet went down crossing Mexico, and the other one went up to Canada. And in this area, it's like a high pressure. It's an area, a barrier for the moisture. So all the moisture from here went up to the north and through Mexico. And that created a strong drought in this region. And we can see here, this is the droughts of the 2015 year. We can see here how it is drought in this area, but it is wet here where these currents advected or transported moisture to the north. And also here in Mexico is sort of wet, and it was partly because of this current went down than we further down than we expected. And this, for Scripps climate scientists, it created a problem, and well, not only for them, but for everybody who forecasted this year, because the forecast was that it would be wet as the common, as usually we expect, but it changed. So this is one of the surprises that happened this year. And of course, one of the questions is this because of climate change? Especially because of this warm waters that were not over here. So there are some scientists have different hypotheses that what may have happened, but partly it could be, but it is not for sure what is the reason. So the jet streams or the winter storms in here, part of the moisture that we receive is because of the atmospheric rivers. Atmospheric rivers was coined by Murray Rolfe, like, I don't know, like 15 years ago, here from Scripps and his colleagues. And he basically put atmospheric rivers on the map. Before, of course, we had entrance of moisture to the continent. We call it in different ways, but was his work who basically put atmospheric rivers in the map. And now there is like a boom of studies working on the impacts of atmospheric rivers and how they behave and if they hit one part or another of the country. In Mexico, we haven't done much work on that. I have two words that relate a little bit on atmospheric rivers. In the past, in the 90s, these scientists, Rasmussen and Mo, they coined a phrase that it is called the Mexican connection, and they call the Mexican connection when these currents over here crossed and advected moisture from the Pacific to the Gulf of Mexico. And that happened mainly when there were very strong El Niño events, like 1982-83 and 97-99, in 92-93. So we did some kind of work related with the Mexican connection, and yes, we found that there was a lot of moisture coming into Mexico, and we found that these atmospheric rivers occur most commonly during El Niño and neutral years. However, there are more surprises that I will show you later about the atmospheric rivers. Drought and water is something very important in our region. because of this high variability. And this is the area of drought from 2002 to 2024. And here is the El Niño 2015. So we expected a very wet year for both Baja California and also for Baja California, but instead it was pretty dry, very, very dry. And then in 2017, which was a La Niña year, we were expecting dry conditions, but it was wet. There is almost no dry conditions in 2017 and also in Baja California. Then another surprise came in from 2020 to 2022, because there were 3 years that we had a La Niña event. So it's when the jet stream, these winds go up to Oregon and Washington and keep dry, doesn't allow the entrance of moisture to our region. And therefore here, these 3 years were dry as we expected. However, the surprise was that there were 3 continuous years of these events. So that's why our region, sometimes we can have a wet year, and then 3 or 4 years without water. So we are used to that, but we need we have strong impacts in the region because of that. So I want to show you something nice, and this is another climatic surprise, and this is the amazing La Niña 2016-2017. And it is amazing because, well, it was a weak La Niña. We expected that there wouldn't be much rain above normal, but in fact, there were many atmospheric rivers. Studies by Mary Ralph and the team here in Scripps, they have found that there were much above normal atmospheric rivers entering here, and not only here, but also too in Baja California. We had beautiful entrance of, there are beautiful satellite pictures and that I want to show. And of course, this has positive and negative impacts. Always when we have extreme events, we may have positive, we have benefits because we have water for the ecosystems, water for the dams, snow in the mountains that later will have runoff for the Colorado River, for example. But also we may have floods and landslides. And as I mentioned before, impacts generally are stronger on the south of the border than in the north. But we have seen disasters also in California because of the floods. And the other thing is that there was abundant wildflowering in 2016, 2017. Here are some of the beautiful satellite pictures that occurred that winter, especially from January to March. There were more in that period. And one of the reasons is that this warm blob, these are sea surface temperatures over the Pacific Ocean, and it was pretty warm. And possibly that was one of the factors to have the jet stream moving close to our region and transport moisture to both California and Baja California. And some of the wildflowers that I took that spring in 2017. And here in Baja California, we don't have rivers. We have only arroyos. Those are seasonal currents. And the Arroyo Guadalupe, it is located in the wine region. Mexico, actually, the Guadalupe Valley is the main wine producer in Mexico because this is the southern tip of the Mediterranean climate, which is pretty good for the wine grapes. And the Arroyo flooded several times in 2017, which is very unusual to say it. So winter storms have, as I mentioned before, positive and negative impacts. The snow falls in California, in Baja California, in Arizona, in New Mexico, etc., but also floods. And these are related with this structural or urban development, this maladaptation, unsustainable urban development that we have, particularly in Tijuana and other cities, of course, but Tijuana is very clear because we cross to the border to San Diego, and sometimes we don't see that there is a flood, but south of the border, we see it. Not always, but in some cases. This is, I showed this one because I love satellite pictures, because sometimes they're like very, very artistic. These two cyclones here are related to this flood in, that actually, the flood was also in San Diego for this particular case. So it's very pretty. And during the summer, even though this part, like Baja California and California, with the Mediterranean climate, we are not used to have rainfall because of this high pressure that acts like a barrier for the moisture. Sometimes when the ocean is warm, we can have some storms. And here is this satellite picture. I like it very much. Because you can see the towers up in the mountains. And these towers can be like 2 kilometers high. And these are produced because the continent gets hotter than the lower part, and that produces advex moisture and create these beautiful convective towers. And these convective towers produce rain in the mountains, and that helps to fill aquifers. For example, in Baja California, in this part of Mexico, that there are no rivers, we have aquifers, and part of this convection serves to fill the aquifers. Here is also the monsoon, the Mexican monsoon, the let's call it North American monsoon, because it's part in Mexico, but also arrives to Arizona and New Mexico, and you can see the towers, also the convective towers related with this heating. The monsoon are related with heating over the mountains. When there is more heat in the mountains than in the ocean, then we have this beautiful cloudiness and rainfall. And of course, I'm sure you have heard that in Arizona, there are many flash floods. Flash flood is very common, and it is when it is really hot over here and we have these towers, and they produce all this amount of rainfall in a matter of few hours, and that's it, and it floods everything. We also have seen lately some hurricanes coming in close to this area, like Hurricane Payne in 2016, and this is Hurricane Kate. I wanted to show you the Hurricane Kate in 2022, because 2022 was a very extreme year all over the world. And here in our region, it was the ending of a La Niña year, which is very cold. It's cold waters here in the equator. But you can see that it was really warm in front of Baja California and California. And that allowed for this tropical cyclone to go up to the north. So one of the things that we are worried, or things that may change with global warming, is the warming of the oceans. Because warming of the ocean will allow for different systems to form in regions that they were not common to have them. Like, I mean, tropical cyclones have crossed to California in several times during the century, but it's not that common. And it is not common because we have the high pressure over here, the one that I have mentioned several times. Is so important for the Mediterranean climate that when it's there, it doesn't allow for the tropical cyclones to move. So it goes down. However, when it's warm, like here, the tropical cyclone will migrate to the north. 2022, it was a year of global extremes. You may have read in the news a few years ago that in Europe, several rivers were dried out for the first time in many, many years. In Mexico, we had here in my city, I'm from Monterrey, Mexico. Here is south of Texas. And in 2022, we had what is called day zero. The day zero of a drought means that a city doesn't have water for society. And the day zero have been reported in Cape Town, in Australia, in Europe in 2022, they were near day zero because of heat waves and drought and need of water. But I wanted to mention in particular something that occurred in our region. And from 5 to 7 September 22, we had a heat wave that it lasted possibly 1 week or a little bit more than a week. But the most amazing thing about that heat wave is that it affected from Baja California to Greenland. And the heat wave in Greenland was the first ever recorded. And that occurred in September. And what happened is like when we see the seasonal melting in the Arctic, the major melting occurs in July, which is the hottest months of the year. However, in that heat wave, there was a huge melting. So that was another call for the world that many things are changing in our climate system. Circulation, extreme events, a lot of impact in society are happening because of these changes all over the world. So 2023, 2024, this is the last year I wanted to highlight. This past winter, there were several atmospheric rivers in this region, and that's why here in California, in this area, there is no drought. This is the drought from the North American Drought Monitor, and the red is the drought. But here, the California area was impacted in a positive way by atmospheric rivers, and therefore we don't see any drought in here. But in the south of the border, in the Mexican monsoon, we had a weak monsoon, which means that didn't rain. We had a very heavy drought in the Mexican side of the North American monsoon. And however, the other thing that happened in 23 is because this was very warm, this area, so we had the entrance of Hurricane Hillary. I suppose you remember last year in August, we were expecting, and there were, the trajectory was all over the news. And of course, it produced flooding and landslides in Southern California. It arrives to Los Angeles and San Bernardino and things like that. And it was because, again, this part of the ocean was warm. And when it's, I highlight this because when this is warm and the continent also is warm, like what we expect with global warming, then there is no land-sea contrast. And for the monsoon rains to happen, we need to have this warmer than the ocean. So this happened the opposite as we expected. Now, I want to put the drought of this region in a much larger perspective. just to see what is affecting this area. This is from 1950 to 2023. And we can see here, these negative values here mean very dry years. So we can see that from 2000 to now, we have been experiencing a mega drought in all this region. Of course, there are from time to time 1 year that is wet, but on average, in the long term, we can think that this is a mega drought. And before that, there were more wet years. And there are many studies on droughts in the United States and many other regions of the world, but for the United States, we know that droughts are very much related with the state of the oceans. If the oceans get warm, then something will change. And for our region here, what we have found is that when the Atlantic Ocean is very warm, then in this side of the continent, it will be dry. When we do forecasts or models to predict what may happen in the future, we look for indicators or a variable that can correlate in some way and try to forecast and predict. So here, what we found is that when the Atlantic is very warm, it rains over the Gulf of Mexico, but here it gets dry. So what we found is this Atlantic multi-decadal oscillation. When it's warm, the Atlantic we have the mega droughts, and when the Atlantic Ocean is cooler than normal, then we will have wet years. So this is one indicator, but there are others. Why is this important? Is because we need to predict in some way what may happen next year. Lake Mead, I mentioned before that Baja California receives water from the Colorado River, and one of the indicators to see if there if the Colorado River has a good capacity of water is to look at the levels of Lake Mead, which is located here. And when we see the time series, this is from 2002 to 2023, and the capacity of the river is 40%. So it is very, very dry. The waters of the Colorado River are very low. In fact, and this is the size in 2000 of the lake, and this is in 2022, much smaller. And we know that the Colorado River delivers water to several states in the West and also to Mexico. And a few weeks ago, Mexico received a notification from the US government that the water that should be delivered to Mexico as a treaty, international treaty that they have, will be sent until 2026 because the lake has very little water. So this impacts all the ranchers and the region over here, and we need to look for other sources of water or to change the way we use water. Agriculture takes like 80% of the general water is used by agriculture. So something is wrong in the way the agricultural sector is using water. Baja California, the border region of Baja California depends, 51% of the water is from the Colorado River, and the 30% come from aquifers, and most of the aquifers in northern Mexico, in the west side of Mexico, they are overexploited, or they have been polluted by agrochemicals or salinity. So we have a very important problem, social and economic problem in the West. And these are some of the products that depend on water in Baja California. So 2023 was also a very extreme year worldwide, because several records were broken, like the temperature, the global mean temperature was 1.48 degrees Celsius above the pre-industrial levels. And this threshold was supposed to happen in the 2030s. But now we have it here. So the scenarios, the climate change scenario that said, no, possibly in the 2030s or in the 2040s, we'll have these increases of temperature. No, we have them right now. We have them here. The other thing that happened, and I saw this picture from a talk that Margaret Leinen gave in Ensenada, in my institution. I was so amazed. This is the warming of the ocean up to 2 kilometers down. And we can see from 2015 and onward, all the ocean, the deep of the ocean is warmer than normal. So this is very worrying, because the ocean has a lot of persistence. Whatever, this heat can be used in positive ways for the circulation, but also will change the circulation to produce extremes in other places that were not used to happen. And of course, one of the most important evidence for climate change is the pioneering work of David Keeling. His visionary work of thinking of the importance of monitoring our environment, and particularly the CO2, was and still is amazing. My hair is still, because thanks to this monitoring of CO2 in Mauna Loa Observatory in Hawaii, it has been proved, this was the evidence to prove that climate change is occurring, that global warming is occurring. So monitoring is very important because that would help us to verify and to evaluate this climate model that we use to produce the projections or the forecast. So that would give us more certainty of what is going on in our environment. And just to give you an example of these scenarios, the future scenarios, the Intergovernmental Panel of Climate Change, the IPCC, in the last report produced an atlas. And in this atlas is a very nice work because it has regional indicators of what may happen in the future. And this one shows the changes of July, August, changes in the days with temperature greater than 35 degrees Celsius. 35 degrees Celsius is something like 95 Fahrenheit. And what we see is that this border region is very sensitive to having more heat waves, more temperature greater than 95 degrees Celsius. And they had predicted or projected that this would happen in 2035. But we are experiencing these heat waves already in the globe, not only in this region, but on the globe. I mean, the mean global temperature is 1.5 degrees Celsius, that it was supposed to happen much later, that we are now experiencing this. So this is really worrying. So just to put in a global context, our region, this is a global aridity index that measures the precipitation and evaporation in the domain. When we have these values over here, means that most of the atmospheric moisture that we have in this region, or in all the regions that are at near 30 degrees north, the atmospheric moisture will be exported to other regions. It means that we export more water than we receive from storms or from rainfall, snowfall. And that's why this region is prone to extreme events and to have these changes, this variability, this strong variability on an interannual basis. The monsoon region has also experienced increases in temperature, not only in the summer, but also during the winter. And what we have seen is that the mean temperature in the monsoon region has increased also 1.4 degrees Celsius in the last 40 years. And that means that is the same rate that is occurring at global scale. And not only that, but every summer since the 1980s is warmer than the previous decade. So this is has an impact on society, on the use of water, on the use of energy, and of course on the health of particularly people who work on outdoors. So here is the, there are many models that are used to see what will happen in the future. And what we do as climate scientists is see if those models reproduce well what is happening in the historical period. So these are observations where this 95 degrees Celsius is occurring, is in this area. That's why I think that the US-Mexico border region is already a climatic hot spot. It is really warm because of the extreme temperature. It is common to have heat waves in this area, not only during the day, but also during the night, and even humid heat waves, because during the summer, the Gulf of California is very, very hot. Therefore, there is a lot of evaporation in this area, and therefore it produces wet heat waves. Those are very problematic for young people and all people who have a heart problem, for example. And of course, the droughts. The trend in the droughts in this region is negative, and we saw that during the 21st century, we have been in a continuous mega drought. The future projection that we have seen is that if we only use precipitation to produce the future scenarios, it seems that it's not going to happen anything. However, when we use precipitation and temperature at the same time to produce the drought, because the droughts are related, if it doesn't rain, then the temperature increases in a region, and therefore using precipitation, evaporation, or temperature, we see that in the future there will be more droughts if warming continues in a global scale. Precipitation may also change in the future, and it depends which model we use to produce the scenarios. What we see with these models is that it may rain a little bit more than it is now, but this has a lot of uncertainty because there is a lot of interannual variations. If we see the time series, I didn't want to put too much information here, but when we see from one year to the other, we have wet years and then a train of dry years, so there is a lot of variation. But what we have seen is that of this possible rain that will occur here, 10 to 30% of this rain will come from extreme events. And that is very much related with the warming of the oceans and the changes in the moisture that is transported by the winds to the continent. and the position of the jet streams. The other thing that we have seen is that there will be more days without rainfall. So when it rains, it will be rain more. And just to close my presentation, there are many challenges as a region, as a country. I know that, for example, the state of California and even San Diego, it is upfront in climate change assessments. In Mexico, with our current president, who's gonna leave this year, climate change was not a priority. So we are behind in climate change assessments in Mexico. So this figure, what it shows is that we need monitoring, we need information in order to know and to validate and see if what is changing is an evidence for the changes and to understand the impacts. As climate scientists, we use the data, we do forecasts, projections, but it is very important to do transdisciplinary work to talk with all of you. What do you feel? What do you think is going on right now? And with different actors to be able to translate this information and to know which variables or which metric we should use to give to an agricultural rancher or people in fire, for example. And it's having this information, this knowledge, we can influence in some way policymakers through different channels. Because in many occasions, the ones who can change what is happening or the strategies that we want at the state or municipal level is through the policymakers and the government. So we need to do that. And there are many different climatic drivers, like the ones I was talking about. But in order to adapt to these climatic drivers or climatic impact drivers, we need to work not only on mitigation. Mitigation is reducing the greenhouse gases and having renewable energy, but we need to do adaptation strategies, particularly structural changes. Like I was telling you about, we have a flood, but that flood possibly is not that huge, but it is the way the city is constructed. Or for example, how do we mitigate or adapt better, to feel better, to have a better life in my own house? If we don't have air conditioner everywhere, and some places they don't have that, but maybe you have a higher house, the ceiling is higher, and you have insulation in the house. The way we build houses may be a possibility for our future. So there are many innovative and technological ways to improve the way of our life. And of course, reuse and recycle water is very important for regions that are prone to droughts. So this is a work of not only the scientists, but also the society. And it's very important, the collaboration. Thank you very much.
Thank you very much. I'm curious about what creates the high pressure system off the West Coast. What keeps it that way?
The planet has different centers of action, and one is over the equator, and in the equator the winds converge from one side of the one hemisphere and the other hemisphere, and they produce convergence. And because it's warmer, because most of the more heat comes to the center of near the equator or the tropical regions, and that's why there is convergence. And then going up, the moisture goes up in the atmosphere. So when it arrives to the upper part of the atmosphere, the winds have to go somewhere, so they go to both sides of the hemispheres, and then go down somewhere, and it is at 30 degrees north. And that produces these high pressure cells. That's why we have in the northern hemisphere, in the two oceans, and also in the southern hemisphere. And we call them subtropical highs, or subtropical anticyclones, because they are opposite to a cyclone.
Can you briefly tell us how you became a climatologist?
Well, when I was little, I loved to see the sky. Well, still, I love the stars and constellations. And but the summer in my hometown many years ago, it was pretty dark. So it was very enjoyable to sit outside with the family after dinner, and my mom used to show me the constellations. So for many, even up to when I was 21, 22 years old, I still wanted to be an astronomer. But I did my bachelor thesis on cloud physics, on cloud seeding. And I became very interested on the atmosphere. And I say, well, if an astronomer can study the atmosphere of other planets, why not to start with our atmosphere? And that's how I became interested in doing meteorology and climate later. And I'm very happy of my decision. Even I still watch the sky every night. but the auroras, I don't know if anybody saw the auroras, but it was overcast yesterday or 2 days ago. So in Ensenada, we couldn't see them.
Thank you very much. We're very happy that you chose to become a meteorologist as well. That was really a wonderful presentation. Thank you all for coming. Let's thank Tereza again.